Welcome back to the Niagara Learning Channel. So from the last video where I was showing you how to change the passphrase and the username of the station that was sent to you to load onto a Jace 8000 controller, because I didn't know what the passphrase was and I didn't know what the username was, I continued to look at the logic that was on that station. That was video #156 named change passphrase and user, and I didn't, the software probably worked. It was sent to me because the client had an issue with making the software work, and he also wanted CHP software to be added to it, and I didn't want to add the software to somebody else's logic, so I deleted the software. So I kept the file structure, as you can see here with the backnet points from the last video. Let me go to backnet device manager and load that up. Come on, why are you taking so long? Put you on pause. Right, I don't know why that took so long to load, but if you remember, we had these backnet points here, and we had the DIs for the boilers, plant room supply fans, and the digital outputs for opening up apparently just an on and off, open or closed valve for the CHP thermal stores. But then I noticed some other points at the bottom, and that was on the next one, where we have got somewhere some analog outputs. They're the plate heat exchangers. We do have some analog outputs. They're pump speeds. So I'm trying to find them. 4 valve positions. I know why I can't see him there in the points, because they weren't in the points for the CHP. Let me just pull up the panel drawings for you. Let me bring that across to there. Come on. And we have got for CHP somewhere here. So there's your CHP enable common fault, gas alarm, mains failure, etc., and Modbus connection to it, which I don't know what the Modbus codes are. That would have to be sorted out on site. But I think it was right at the bottom they added another sheet. Generator page intentionally blank. They added another sheet. Here we go. CHP thermal store number 1 2-port control valve, and CHP thermal store number 2 2-port control valve. So I went through the panel drawings, mixing control valve and 3-port control valve, and added them into my points on my CHP. Now let me minimize that and bring across the CHP drawing, mechanical drawing that I was working to. So there's our CHP here, and we've got a temperature on the return coming back, BMS, to this valve here. So this is a CHP 3-port valve. You see it just there, and that stops coming up. We've got a heat meter here and temperature sensor for the heat meter on the return side, flow side, and one on the return side. And this CHP has its own shunt pump, which is here, which is actually BMS controlled, allegedly. Saying that, it goes from there into the interface and then BMS there. But they've got it on the drawings, on the panel drawings, that we're enabling that shunt pump. So we're enabling the CHP, we're enabling the shunt pump, and then we've got a return temperature sensor that we're controlling the 3-port valve on, according to these drawings. We've also got a temperature sensor up here, and we've got another 3-port valve, which is our mixing valve into the boiler system. And then we've got our 2 CHP tanks, storage vessels here. Now, I normally don't see this on CHP. Normally, from the storage vessel here, the top would normally go into the bottom, and they'd be in series with each other. So that is actually the bottom there going into the top. So we're always going to be the coldest there, and we're always going to be the hottest there. And if this is the one out, then I would say that we would get rid of this bit here. But I'm not mechanical, so this isn't being drawn by me. So, and we would put them in series. So, i.e., take that pipe and put that pipe into the top of that, and then come out there. So that would be our return through there. The hot water there would then go into the bottom of that tank, and then just one outlet going out. But they've done multi-arrows there, so they're saying it's multi-flow either way. We'll wait and see when we commission it, but I normally don't see CHP systems for tanks like this. I normally have the 2 tanks in series, and we condition the full body of the water, because we all know water will take the shortest route. So I think they've put the valves there, the mechanical valves down here, so that we can actually close one down, treat one tank, and then once that tank is treated, open up the other valve, give it another body of water, and treat that tank and close that one, I presume. And it's all going to be in the commissioning stage. So that was a bit of an issue for me on the mechanical drawings. Right, let's go to the logic. That's what we're here for, logic. So I deleted, like I said, all their software, and I did my own. So I always start with the time clock. So I left their time clocks in there, but I composited them out to the outside of the folder, and you got composite here. And all you do there is take the time clock out, double click it, and basically bring it to the outside of the folder. And I've done that with all my folders, so we can physically see what's going on. So after I did my time schedulers, I thought, okay, let's start on my safeties. So we went into the safeties here. Now, I noticed from the safety we didn't have a pressurization unit. So normally I would put a pressurization unit in there, and let me just add that anyway, even though I don't have a point for it. Pressure unit. And pin slots, take out in 16, and we'll make it fail safe, so that would be healthy, and that would be fault. Save that. Actions set to healthy, so that would be a true, and then we would put that into our AND gate there, and we'll name that views AX slot sheet pressure. Just in case they decide that they're going to add it to the points at a later date. And I'll show you the composite now. See, I've just done that one. So go to safety, right click, composite, pressurization unit, in 10, come up there. I'm just going to move it up one, so all my ins at the top and my outs at the bottom there. Go OK. So it's come up false, it would have put it as a false. Just going to click on that nib, and there's my safety here, and that in 107 is my pressure. So view AX slot sheet pressure. I'll put LTHW pressure, and I'm just going to do a Boolean writable here, temporary one, set that to true, and then take it from there, put it into there, and then I'm going to delete that. But I don't have a point for it, and as you can see, there's no point. I don't have anything to link that up with at the moment. So that's my safeties. So we're looking at all the safeties here, and some of them we're changing the signals because they are healthy in a false state, and I want everything to be true in a healthy state. All into AND gates, and then link them all there, and safety OK, which we've got true. Naturally, any one of these is changed. For example, that one, inactive, is healthy. Let's change it to active. We've got false there now, so we haven't got this. We've got a safety issue. Put that back to emergency auto. So that was our safeties. Just one nice little folder with safeties. Brings us out here. Now these safeties are going to all my different blocks. We'll come across that later. So last time when I did this, the next one I worked on was a plant room supply fan. So basically the supply fan has got to be running for the boilers or the CHP to start. So looking in here, we had the time scheduler. We had our safeties, that's took in another block. Supply fan fault from the points, supply fan running from the points. And all I did there was my AND gate here, put my scheduler, my safety and my fan healthy in there, because a fault is a true signal, so I had to use this NOT gate here to reverse the signal. And that went, as soon as my safeties was okay, my scheduler was asking for the heating to work, and the fan wasn't in fault, we could then enable the supply fan. And all I did with this is I fitted, I installed in that at the bottom a discrete totalizer to give me the time starts and the hours running. And you can that can easily be reset on commissioning actions. Reset, so we know the physical hours it's actually been running. So that enable is going out to the point. Again, I composited it out on the point, but I'm also taking that to a mismatch alarm, fan enable and fan running. So at the moment that's an XOR gate, so because I've got two trues, I've got a false there. If I've got two falses, I'll have a false there. Any one of them different, I'll have a true. So if the fan is running and yet the DP flow switch is not, that's gone true now. So now I'm waiting 30 seconds. I've made it adjustable. And again, with all my set points and adjustables, you've only got the set. So I hidden the rest of the points. Again, how you do that is AX slot sheet. Click on emergency, override and auto, and config flags, and tick the hidden one there. And after 30 seconds, which has just gone, you've got the alarm there. I also took this alarm, this point here is just me compositing it to the outside of the folder. So when you're looking at the main folder, you can see, oh, you have an issue there. It's red. So it was just easier to see, supply fan issue. And then the speed, fixed speed. Again, I made it adjustable so they can adjust it on the graphics. When we switch on the supply fan, we're just going through this numeric switch and switching this 80 through to the supply fan speed and again to the outside. Let me put that back to normal. That's the alarm now gone off. So that was simple enough for the plant room supply fan. And then after that, I started on my pumps. And I knew I've got 3 pumps for the primary, and I know I've got 2 pumps for the secondary, and I know that the secondary pump speed is controlled via the riser pressures. So I didn't do the riser pressures first, I did the 3 pump one first. So we've got our enable frost protection, which we are not using. There was nothing in the DesOps or anything with regard to frost protection. This would be running 24/7. Excuse me. And we got our safeties. We also don't have a DP, one DP for that pump set. What we've got is a DP, but per pump set, but it's on the run. So hence that's why you can see these are in here. These are the points, the physical points that aren't connected yet, i.e. we haven't got it connected into the panel with the I/O modules. But we do have faults for the pumps. No, we didn't have faults either, if my memory serves me right. Yeah, we had no faults coming in for them pumps, but they're there. If we do need them, they're there, ready to put in. Set point for the run on 300 seconds. So when we turn the pump off, we've got a delay of 5 minutes, 300 seconds there. That's all that's going to from there. All I'm doing is taking 300 seconds that they can set, timing it by 1,000 from seconds to milliseconds to then put it into the off delay. So it's not a, I could have left it as a fixed 5 minutes, but the client might want to adjust that and say, well, you know, I want it to run on for 10 minutes. They can. And then of course we've got the pressure speed, 80 kPa they're looking for, and I'll come to that bit in a bit on the other folder that I've done for the riser pressures. But all I've done is taken the minimum, but I've added minimum, maximum and average blocks just so that I can choose when commissioning which one to take, but it probably be the minimum. Going into a loop, speed loop point, control variable set point. The loop is enabled from the main enable and all the safeties are okay. I put an on delay of 7 seconds. It can be 1 second, or it doesn't even have to have an on delay, but I just thought I'll put a timer in there just because we can, and we might just want to delay it before we actually start things, i.e. get the other things up first and then delay it for a few seconds. I haven't given an adjustable on that one, we'll just do that when we're commissioning. So that's going into our pump rotation. So it's a normal block, pump rotation block that you can find in your Vicon Pro. And we've got our feedbacks there of our 3 pumps, our run times of our 3 pumps. So again, that's just putting a discrete totalizer on these points here and bringing out the elapsed time active. And then we've got our delays. So basically we will switch on a pump like it has done here, pump A and pump C. Now what we've done is we've told it it's got 3 outputs, but the only loads that we're using are 2 loads. So lead lag basically, lead standby. And if a pump goes into fault, we can then go to the second pump or the one that's not working. And then we just go into a simple folder there, enable healthy, and then out to pump A, pump B, pump C. So currently we've got pump A and pump C running, and the speed, again, we just use numeric switches, and when we've enabled that, yeah, we will want the speed there to actually come through to the pump. You can see I'm bringing it out on the output there. The other way of bringing it out is actually not there and going to the physical output on the I/O and bringing it into there, but I didn't bother. I think that's it. We've got some status demucks here, and all they do is monitor the alarm, and if it's in alarm, and then if it's in alarm, we basically send that to a false to switch that off and to start another pump, regardless of the delays before that. So even though we switched it off there, it will stop immediately. There won't be 5 minutes, because we've basically stopped it at the end of the logic rather than at the beginning of the logic. And that was exactly the same for, once I wrote that, I then used that exact same one for the 2 pumps. All I did was delete a pump out and change this from a 2, from a 3 to a 2, and required load 1. So we've only got 1 pump running, it goes into fault, it switches to the next one. So that block was actually simple, because I just had to delete the third speed, the third pump. Then from there I went into my riser pressures. So I took all the riser pressures, A, B, C, D, E and F. I put them into a minimum. I then thought, I know I'm going to use that, but while I'm at it, I might as well make a maximum block, an average block, and then I can bring the points, I've got the points here, minimum, maximum or average, and just expose them out, and I can then pick which one I want to use for the top riser pressure, which will probably be the minimum, but it was nice to just have the option while you're on site commissioning to pick another one if you wanted to, for the pump speeds for the LTHW out to the risers. Then I worked on the plate heat exchangers. So I got my start heating there. So that's taking all my safeties, my time clock, everything like that, as you know, supply fan running, etc, etc. So I didn't need to bring that into my plate heat exchanger folder, but I made one plate heat exchanger folder. So there's my start heating, and I've got my loop there, my control variable. I took the secondary and the return, both of them, and just took the maximum. Now we can actually change it, and we can not have, we can just take the flow temp only per sec, but I just thought, sod it, I'll take both of them, take the maximum out of both of them and put it into my control variable. That way I've got no arguments with anybody on that one. And then my set point of what they want, 75, to then open the valve. So set point, as you can see, is 75 at the moment. Control variable, I've set it to 80, so that valve is actually closed. And then we had a high limit shutdown. So if the plate heat exchanger went to 90 or above, I wanted to shut down. So all that was is I took the same maximum out of the 2 temperatures, put it into a less than block, and long as I could have used a T-stat, but I used a less than block, 90, then it will actually, it goes into this and secondary high limit is less than high limit, but if it's greater than high limit, that would be false, which would basically, if that valve was running through this numeric switch, that would then go to 0. So let's get this this running. Let's just put in a temperature actions emergency override, and let's put something like something low, 50 degrees in there. So that's now starting to ramp up, as you can see, and that's ramping up. But let's now go to a high limit. I mean, once it gets to 90 anyway here, it will back itself down and close it. But in case that wasn't working, or that valve was stuck on open and it was faulty in any way whatsoever, then we want to shut this down. So let's fix that. Actions, emergency override, and let's fix that where it is at the moment, 81. And then I put that to 90. And put it to 91. That's put that straight down to 0. It's closed it because it's greater than 90 degrees. So it's basically broke the AND gate there and switched that down. We shouldn't really need it, but it's there just in case. Let me put that back to normal. Emergency auto. But what we could have done, instead of using the less than, we could have used a T-stat. And sometimes that's a preferred method for people. So I'll put a T-stat there. Sec temp high limit. Might as well just put it in here anyway. We won't use it, but it's there to be used. We want to pin slots, set point, control variable, differential. So control variable is this one. Set point is this one. And differential we'll put as 2, so that's 1 degree either side. False, that action needs to be that way, I believe. Let's see, let's test it. Let's get to 90. Emergency override, 95. We've now gone true there. So I want that to be true at all times and false, so I want it the opposite way. I don't need to put a NOT gate in, all I've done there is just reverse it. So when we're actually below, we've now got the true. So that one will work. That one, probably better to be honest. Slightly better. So let's let us take that one out. Pin slots, expose that, and bring it into that one there. And leave that in there. And we'll leave that one in there as a, let's put a note there. Second option. We'll give it a yellow background and we'll give it a border. Save. But we don't need it. That's good enough. That extra one there, but that's there just in case. And then all I did with that, after I did that block, is duplicate it. Simple as that. So you find that that's not in that block there. So let me just take that and that. Sorry. Take that and that. Copy it. I'm just going to paste it straight into that block. I want to do it on this side here. Paste it into there. So I've got the exact position there. And take that, put that there, take that, put that there. Set point, control variable. Take out that one. Pin slots, expose that, take that and put that into there. So now we've got an exact duplicate. Well, that was for the second plate heat exchanger. So the plate heat exchangers are, when I find you, up here. Oops, too far. Too far. come across a little bit. There's the two plate heat exchangers here. Plate heat exchanger 1 and 2. Temperature, pick valves, pressure independent control valves there. And that's what we are controlling, them pick valves. This is our secondary side. This is our primary side. This is a side that's coming from the boilers and the CHP. That's our secondary side. Our secondary pumps, our two pumps there that we've already looked at. There's a heat meter there, and that's going to the buildings, the blocks there, A, B, D, E, F. Simple enough logic. There's nothing of an issue there. I've just noticed this, which I haven't put in there. Yeah, the BMS is V inverters, variable speed drives, VSDs. So we can see VSD there. But I've just noticed this pick valve here, which isn't in the drawings, i.e. not in the panel drawings, and neither in the points that we've got, which is going to this X-pot unit. So I'm not too sure what we are going to do with this, because if that's controlling, we would need a control variable, and I can't see anywhere, unless this PD monitor, whatever's coming out of that is our control variable for that. So that's something that we need to check on site, and what's that about, because I don't have any panel information about that at this stage. Right, back to the drawing, back to the logic. So we've done all that lot. Then I went to the boilers. So I wanted to put a point in that if I had a CHP fault, I didn't have to wait for the tanks to go cool. I could immediately just say, okay, your CHP's in fault, end of story, let's start using the gas boilers. Right, so plant required, CHP in fault, into an ore gate, start boilers. Safety's got to be okay. High limit, well, we don't have a high limit on the drawings, but I put a high limit in there because we normally have an high limit sensor that can actually cut out. But it's not on the drawings, but it's there, and you can see it from here that I've not linked it to anything. There, boiler common high limit stat is not linked. There's nothing coming into it at all. So I've just left it as normal. Supply fan DP, so I wanted to know that the supply fan was running, even though this boiler required is also telling me that the supply fan's running. So this is your supply fan, so it's giving me an enable. So I didn't really need that, but for belt and braces I thought, you know something, I'll put that in there just for the hell of it. But I've got the point, so I might as well put that in there as well. So that's my supply fan running. Extract fan DP. Well, I don't have an extract fan DP. Well, we have one apparently for the CHP, but we don't have one for the boilers. So all I did was link the supply fan DP to the extract fan DP. So that's exactly the same point. But we can easily break the point, and if we do have an extract fan DP at a later date, we can put it into there. So we're monitoring both DPs. Both of them have got to be true, so we know that the supply and extract's running. As soon as we know everything's okay, we can then start our loop. So our control variable, I've took the primary heat, plate heat exchanger flow 1 and 2 and put it into a minimum block, and then use that as my control variable. My set point is set currently at 80 degrees. It's adjustable, and I think the client will probably set it as something like about 75 degrees, or even may set it at 70 degrees. But I've gave them an option there of what they can set it at. In here you can see minimum 65, maximum 90. So they can't go above 90 and they can't go below 65. But they can go in between them ranges. And then what we do with that is we don't do our boilers yet. We go to our boiler rotation folder. So at the moment, our rotation is boiler 1, boiler 2, boiler 3, boiler 4 standard. If I fire that one shot there, you will see this change: boiler 2, boiler 3, boiler 4 and boiler 1. Fire it again. Boiler 3, boiler 4, boiler 1, boiler 2. Fire it another time. Boiler 4, boiler 1, boiler 2, boiler 4. That should be 4. That should actually be a 3. So I've got that wrong in my logic. So let's go into my sequencing. And boiler 4, 1, 2. See where I've got 4 again there. That should be a 3. Modify. Okay. 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 Now, because I've changed it there, does it mean to say it's going to change on the front? So let's go back to my front here. That's still going to be the same. Views, AX slot sheet, boiler sequence, right click it, config facets, and then just click that one because that's the one that I've just changed. And that should say it's correct now. Boiler 4, 1, 2 and 3. Anyway, let's go into this. So we've just seen the auto rotate work, and then all we're doing there is we're counting up. We're using a counter every time we fire it, and we're counting up there, and we're resetting the counter at 3.10. So that gives us our 4 boilers. There's our PI loop coming into here, and this is a boiler off delay of 5 minutes that's in there at the moment. So there's your 5 minutes. So there's your staging of the boilers: 1, 2, 3, 4, 2, 3, 4, 1, 3, 4, 1, 2, 4, 1, 2, 3. And then all I've done there is gone straight into OR gates. So if I click on boiler 1, you will see we've got boiler 1 there, boiler 1 there, boiler 1 there, boiler 1 there. Click on that one, boiler 2, boiler 2, boiler 2, boiler 2, so on, 3, boiler 3, boiler 3. Makes it quite easy once you actually name these and don't just leave them as default. You can follow it quite through. And then this is your enabling of the boilers. So at the moment it's asking for all 4 boilers to be used. They're all true anyway at this moment in time. And we are currently using 4, 1, 2, 3. So this is this one that we are currently using. And you can see the PI loop there. And we're not using these blocks at all at this moment. Let me just move that up to there. So this is the block that we are using currently. And we have a delay of 5 minutes. That's an on delay and an off delay of 5 minutes. Right. Move that across. So that's our boilers. So we select our boilers. So we only need to go through one folder because all the other folders are the same. So we've got our demand on there. Any boiler fault, there isn't got a boiler fault, it's healthy. So our demand is going there and we're healthy for opening up the valve. So the first thing we do is open up the valve. The reason we've got that is for exercise, valve exercise. So once a week or once a day, depending on the time clock. And the time clock is over here. Time clock's here, valve exercise. Every Sunday between 1 and 2 o'clock. Let's go back a bit. Go back into our 4 boilers, boiler 1. So that is that. Boiler off delay, 10 minutes. Reset, valve exercise we just discussed. Whether it's open or not, the back end boiler, boiler flow temp, boiler set point, which is from the main set point, which is boiler flow set point, which is here. That's your main set point. And damper delay, giving it 180 seconds for that damper to open. So what we're doing there is we've opened up the valve, we wait for the valve to open. So the next one is demand, healthy, differential, and the valve end switch. The differential we're not using, differential pressure. They don't have it there, but I put it in there. It's sometimes standard, but you will find if I follow this differential pressure switch through, it won't be connected. See, it's not connected there. But normally it's standard sometimes to have the differential pressure across there. So I've kept it in there. And then once we are happy and we've got the end switch, we will enable the boiler. And depending on the differential between the control variable and the set point, we will use it for power. The boiler may not have power, it may just be enabled only. In fact, I don't think it has got any power, these boilers. Let me just move that across there. Modulating boiler. No, it doesn't. It doesn't have any power at all. So it's not connected. So it doesn't have that facility. But it's there if we ever want to give it that facility. We're checking the end switch there. Now I've set this to 4. But it's just checking that an end switch is, and depending on how many boilers are working, depends on the primary LTHW speed. No one told me how they wanted the LTHW speed working, but I thought, well, you know something, you would want it faster with all the boilers than what you would probably want with one boiler. Again, we can just set that speed, but at the moment I'm using it on the boilers, and I just set 100 for all 4, 90, 80, 70. They would change on commissioning of what speed that LTHW primary pumps. We could actually put another one in there, speed for a CHP, when the CHP is on, but I haven't bothered. Probably, depending on the commissioning. I'm not a commissioning guy for pumps, so they will tell me once they balance the system what speed they want their pumps at for different scenarios, for boiler 1, boiler 2, boiler 3, boiler 4, and i.e. one boiler or all 4 boilers, or all 4 boilers in the CHP. And it may just be that all 4 boilers in the CHP is 100%. I don't know. Not until we get to site and someone gives me some figures. But we've got contingency in there ready to add or change these values. So we've got to start primary pumps there. So I'm starting the primary pumps, but what I normally use this and the valve open, but then I thought to myself, we want the primary pumps to work for the CHP, regardless of the boilers. So if boilers are not working, we don't really want the boilers to work. We want the boilers to not work at all, and we want the CHP. So I also added in the 3-port CH valve set point. So I took the boiler set point. All I've done is take it to there so I can bring it out to my CHP. So I can bring it out straight to my CHP logic. So I know what the boiler set points are. So making it as simple there that, yeah, this logic blocks in here knows that the boiler set point is at 78 degrees. But back to this again, the reason I did this way is just an all, is that's going to be extract fan running, safety and required is going to be the same command to the CHP anyway, that we're ready to heat. So I thought, you know something, I'll put that into an OR gate for now, just in case, because we really don't want the gas boilers to work, so we don't want any valves open. So we're better off having it that way to start the LTHW pumps on the enable signal, on the heating enable signal, which is the same heating enable signal that goes to the CHP. Again, it can be changed. And then the CHP, so the start heating signal is the same start heating signal as this one here. So if I click on there, you can see it going into there, and you can see it going to there. Same signal, as well as going into the secondary pumps and pH1 and pH2. As for this one, the enable pumps there is coming from this start LTHW primary pumps, as I explained, but as long as we've got using this one here, I put a note there, I did just in case boilers are not required, you still need to run the primary pumps. So there you go, I added a note in there anyway. Okay, I have no points for the CHP. They didn't give me any points, but I went through the mechanical drawings and I went through the panel, so I knew what points was available. So I can't basically bring these to the points, but once the points are in from backnet interface, which would be a backnet IO module, we can add these points in. But the CHP, so I put everything in the CHP. Start heating, plant room supply fan, so I did another check, and CHP thermal link. Again, this is also hardwired, but I thought, you know something, I'll bring it in, seeing I've got it. So all them have got to be on, and my safeties. I added some extra safeties for the CHP. Extract airflow, which I don't control the airflow, so the CHP must start its own extract airflow. But I want to prove that that is running. I don't want a fault. I want to make sure that the gas alarm is healthy and that the mains fail, i.e. we've got mains there is healthy. All CHP stuff. Again, all in an AND gate going to our safeties there. So once we are happy, then we want to start the shunt pump. And I've given a 5-minute off delay of the shunt pump, which again is adjustable by the client. You can see it there. Shunt pump run on set point 300 seconds. So we start the shunt pump. Once the shunt pump's working, I want to get some flow from there. I've done my mismatch again, my XOR gate, and a Boolean delay of 30 seconds. And if it doesn't run, I put an alarm up there. Like we have an alarm at the moment here, because I've got a mismatch, but I've got flow, but we're not enabled. So CHP there, as you can see, is not enabled, and it's not enabled. CHP return valve open. So we basically don't have a we're not running, we're not required. So I've naturally fixed that to running. So let's put in a lower temperature or a higher return set point. Actions set. Now that's bad because I never hidden them, so we need to hide them. So if I put 80 there, and then let's just go and hide them. Views, AX slot sheet, config flags. I missed that. I normally copy and paste them, but I must have done that one on its own and I missed it. That's fine. That's fine. Yeah. Okay. Well, that was a. It doesn't make any difference. Oh, I missed that one as well. Views, AX slot sheet. It really doesn't make any difference, but I just like to, on set points, I like to just hide all the overrides so we can just use the set point. I presume that's the same. It is. Views, AX slot sheet, and let's hide them babies. Config flags, hide. Right, back to CHP. So, we enable the shunt pump, we prove the shunt pump. Once we're all happy, so shunt pump's running. Shunt pump will be running over time when there's a heating enable. Even though the CHP may be up to temperature and we've stopped the CHP, we still want to run the shunt pump. Get some flow running through so we can keep monitoring. So the CHP is now enabled. We've got our XOR with our pump flow, which is fixed at the moment, but that Once we disable, that will also disable and vice versa. So I'm just looking at that. The off delay is 5 minutes for that. And I'm just wondering whether we're going to get a little bit of a problem, because I've got 30 seconds. So I'm giving a 5 minute off delay. We're still going to get, no, it's still going to have flow. No, that's fine. It's still going to have flow, because that flow is monitoring across the pump, so we're not going to have an issue there. CHP enable, we've done that. 3-port valve. So what we did there is CHP return temperature and CHP set point control variable, opening up that 3-port valve, which is that one that was at the bottom. Let me show you. Where are we? I want CHP. So this one is controlling the valve here. This one here. It's controlling that valve down there. Right. And that's my 3-port valve. So we're looking at the return temperature coming back, and we're opening up that valve to the main system, or closing it to just the closed CHP system. 3-port valve. CHP fault, I haven't done anything with that. Now I presume I can just put this here, not airflow, but that one, and mains failure are basically my CHP faults. So I'm just going to duplicate that one, go fault, and I'll put in that one the thermal link. I can take that across to that across to that across to that, and views AX slot sheet thermal link. And then I want that to then be an opposite to a true. So put in a NOT gate, FAU, in there, and then take that and put that into there. And that will send a signal to the boilers. So if I look at that now, that sends my signal to the boilers to say we're in fault. So if any of these common fault, gas alarm, mains or thermal link, the boilers will start regardless, because that will go straight to there. So I missed that one, and good job I went through the logic, but I would have found it in commissioning anyway. Thermal 2-port valve open. So shunt pump flow. So once I prove flow, I will open up these 2-port valves according to the points list. Now them two valves are these babies here, MV and MV. Now I am thinking the way it's done in the points list, they're just open and closed, on and off. But then I also noticed in the control panel I had my 0 to 10 valves for store 1 and store 2, and it's not shown anywhere else on this mechanical drawing. So I wasn't sure whether they've replaced them valves now to 0 to 10 instead of on and off. So what I did is I took both into consideration, because I don't know what they've done there. So they're my on and off, open and closed, and all I've done is use a NOT gate to reverse the signal. So I'm only putting the signal into open, and the other one will be false, and vice versa. When that's false, that one will be true. Simple as that. But then I did my mixing valves, and all I did there is basically take my run and my flow temperature, boiler temperature after set point into the true there. CHP is running true, so we can put that enable on. So basically all I'm doing there is saying, is my CHP temperature greater than my boiler temperature? Yes. If not, don't even think about opening up the valves, because we're not even ready for you yet. We haven't got the temperature. So that's all I'm doing here. So checking it's running, checking that my temperature on my CHP is higher than my boiler's temperature. Otherwise there's no point in introducing the water. That starts my loop. My control variable is actually my boiler's flow after the 3-port. Now you probably want to see where that one was, and it's this temperature here, this 75 here. That's the temperature sensor after the 3-port boiler's temperature. These are your shunt pumps for all your boilers. This is my header. You can see LTHW flow, low loss header, and this is my temperature there. So that's the temperature that I am monitoring. Very critical to monitor that, which links to opening up that 3-port valve. But this needs to be higher than that temperature. If this isn't higher than temperature, you don't want to be opening up that valve anyway. So that's all this does, and opens up the mixing valve. At the moment it's 100% because my temperature is higher than the set point is 78. Control variable is 65 after, yeah, so 65 degrees on boiler side, 78 is the set point. Yeah, let's open up the valve because I've got 90-degree water in my CHP. Let's go for it. Let's give you some heating. These other two here down here is I took the temperatures of each tank, top, second top, third top, that's 4 temperature, and bottom, and I did a set point. I set one at 95, one at 90. They'll probably be both the same set point, but I thought, no, let's just have a set point per unit. I took the minimum, the maximum, and the average, but I'm using the minimum into my control variable. Taking my set point, my loop's enabled via the CHP is running. So my loop's enabled there, controlling the valves. Simple as that. And I presume they're the valves that I've just shown you on the bottom, but then we've also got them valves there, which are also the same valves at the bottom. So I don't know which one they're going to go for, but I've took both instances, and I've used the minimum temperature, but I've got the option of changing to maximum or average if I want to. Not that we probably will do that. I think that is it for that. We've been through the logic. So 4 boiler system, 3 LTHW pumps, 2 secondary LTHW pumps, sorry, 3 primary LTHW pumps, 4 boilers, CHP, risers. I don't think there's anything else to show you. That's how I wrote the logic, and that's how I it gives me a good base to add more to it. I can see what's going on. I can see whether I've got some issues here, faults or whatever. It's just the way I like to write the logic. If you found it interesting, please subscribe and like. Thank you very much for watching.